Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Bueno, okay, let's start our next presentation. I guess there are some people still in the door. Okay. Well, let me present Professor Luis Pineda Cortés from the Universidad Nacional Autónoma de México. He is a scientist in the Computer Science Department of the Instituto de Investigaciones en Matemáticas Aplicadas y en Sistemas, IIMAS, from UNAM. His research and publication focus on computational linguistics, artificial intelligence, and related disciplines. He's going to present the following presentation, the Golem project, a laboratory for the construction of service robots. Let's welcome.
Sí. Buenas tardes, muchas gracias a Microsoft y a CONACYT por la invitación, a Jaime Puente y a Gabriel González. Pues me da mucho gusto estar aquí, veo muchos amigos de mucho tiempo en esta reunión. Yo les voy a platicar del proyecto Golem, que hemos venido desarrollando ya por algunos años en el IIMAS. El Golem es una figura mitológica de la cabalística hebrea. Es un cuento con una tradición muy antigua, parecido al cuento de Adán y Eva, donde Dios crea una figura de barro a su imagen y semejante y le da vida. En el Golem es más o menos la misma historia, nada más que es el hombre el que crea otro hombre a su imagen y semejanza a partir de una figura de barro. Y lo hace desde el conocimiento y la sabiduría, y lo hace en un código secreto, encriptado. Entonces, se parece mucho al programa de inteligencia artificial y se parece mucho a los robots de servicio. Y la historia es que un rabino de Praga, el rabino Low, construyó un robot, bueno, un golem, y no caminó muy bien, no habló muy bien. Se preguntaba para qué servía, entonces consciente de la sabiduría de haberlo creado, pero también consciente de la limitación del producto, pero era muy bueno para hacer cálculos matemáticos. El golem, entonces era torpe para caminar, era torpe para hablar, pero podía resolver buenos problemas logísticos. Entonces, y servía, ¿no? Lo construyeron, de hecho, como policía, para cuidar a los hebreos en Praga, porque eran atacados por los fanáticos. Entonces, era su función, era un robot de servicio de carácter policíaco. Entonces se parece a los robots de servicio. Y a la historia tiene otra connotación más profunda. Hay este libro de Gustav Meyrink, un austriaco, que se llama El Golem, que por cierto era amigo de Kafka, donde se desarrolla la metáfora más profundamente, y el golem, la figura de barro, es el autómata, es el títere, y hay alguien que lo controla. Entonces hay las marionetas, y lo construyen para dar el servicio, pero tiene que obedecer a su maestro. Pero sucede que una vez que está el autómata en el mundo, tiene un atisbo de luz y se da cuenta que hay este titiretero, y entonces se obsesiona por hacerse de su propia control, de poderlo agarrar, y entonces se convierte en una tragedia porque el autómata como que toma conciencia y sabe que la toma en la medida que agarre el control. En esa medida es el dueño de sí mismo, toma conciencia, pero la conciencia es una sustancia difusa que siempre se derrama entre las manos y nunca termina de agarrarla completamente. Entonces, es como la inteligencia artificial, o sea, construimos esa máquina y estamos también en ese dilema, si realmente estamos haciendo este mono a nuestra imagen y semejanza, incluso si puede tomar conciencia. Entonces, cuando hicimos su primer robot y había que ponerle un nombre, pues nos pareció un nombre bueno, o sea, como que encarna mucho la inteligencia artificial, pero también encarna mucho los robots de servicio, y lo bonito del cuento también es que lo encarna en la parte positiva, pero también nos hace ver nuestras limitaciones, entonces hay que acceder a la empresa con tremenda humildad y modestia. Ahora, no es exactamente la visión que se tiene de robot de servicio, el público, como que el público en general, cuando se habla de servicio, más o menos piensa en algo así. ¿No hay sonido aquí, perdón? Bueno, lo que no escuchamos, le dan la orden, la toma, verifica que fue una respuesta adecuada, la regresa, va por los platillos y se los lleva. Eso es el robot de servicio, es lo que la gente piensa, que es un poquito más mundano de lo que estábamos pensando y de lo que estábamos platicando antes, pero las cosas son un poquito más mundanas. Entonces, les voy a platicar un poquito los robots que hemos hecho en el pasado. Este fue nuestro primer robot, este fue el Golem original.
¿Te gustaría platicar conmigo de alguna revista de las que tengo aquí?
Es el tipo de aplicaciones que hacía.
Genial. A ver, muéstrame la revista de la que quieres platicar. Esa revista se llama El Faro, trae artículos de investigación súper interesantes. Ahora muéstrame la página del artículo que quieres que te platique. Ese artículo es interesantísimo. Se trata de una estrella gigante roja a la que llamaron en la época del Renacimiento la maravillosa. Hola, soy Golem. ¿Quieres jugar conmigo a que reconozca algún póster?
Claro que sí, Golem.
Ok, pon el póster que quieres que reconozca para que lo pueda ver. Y ahorita te digo cuál es. Es el lío, jeje. Perfecto, te puedo platicar acerca de quienes me programaron, de cómo funciona, o de cómo soy físicamente. ¿Te interesa saber algo de esto? Mejor reconozco otro póster.
Sí, a ver, explícame cómo funciona el Golem.
Bueno, ese fue nuestro primer robot, o sea, está en español, ustedes lo vieron. Uno de nuestros objetivos de nuestro proyecto era hacer este tipo de sistemas en español, y mantenía una conversación más o menos coherente, fue bastante exitoso, sobre todo con los niños. Y luego hicimos otro que es una cápsula, este es un robot con cuerpo pero no se mueve, entonces alguna gente diría que no es robot, otros dicen que sí. Les voy a dejar la interacción para que vean cómo es capaz de llevar a cabo una interacción en lenguaje natural hablado, resolviendo un problema. Otra vez no tengo sonido aquí, perdón.
¿Cuál es tu edad?
18.
Seguro que tienes 18.
Sí,
Muy bien, podemos jugar.
sí.
Presta atención, enfrente de ti tenemos distintas cartas. De ellas voy a escoger una al azar y tú adivinarás de cuál se trata. Para tratar de adivinar podrás hacerme 4 preguntas sobre el color o la forma de las cartas, o si se parece a otro objeto. ¿Entendiste las instrucciones?
Sí.
Ok, fíjate muy bien en las cartas mientras escojo una. Empecemos el juego. Por favor, hazme tu primera pregunta.
¿Es redondo?
Sí, más bien, lo que hay en la carta es redondo. Hazme la siguiente pregunta.
¿Es naranja?
Perfecto, en mi carta hay algo de color naranja. Vamos, hazme la siguiente pregunta.
¿Es caliente?
Aunque energía pueda tener, en mi carta nada caliente hay. Solo te deba esta última pregunta, así es que piénsala muy bien.
¿Es azul?
Muy bien, veo que mi carta tiene el color azul. Ha finalizado tu ronda de preguntas. Por favor, muéstrame la carta. No tengo muy buena vista. ¿Es esta la carta que me mostraste?
Sí.
Ganaste el juego. Felicidades. La carta que escogí fue Júpiter. Bien hecho. Pero antes de irte, por favor, mira a la cámara. Sonríe. Gracias por jugar conmigo, Adam. Regresa pronto.
Bueno, este juego está en el Museo Universum, en la UNAM. Tiene ya 2 años instalado. Y los 2 sistemas que les mostré ahorita son prácticamente iguales. O sea, la inteligencia de los sistemas, la que lleva la conversación es... Oh, I'll switch to English now. The system is practically the same. So the intelligence that is there in the robot is basically the same system, and the only thing that changes is the perception and action mechanisms that are required for the particular tasks. So I want to talk a little bit about the history of the project, and we had first, before this project, we had another project called DIME, which means Diálogos Inteligentes Multimodales en Español, in which we were studying task-oriented conversations to support people in different domains. So we had a corpus in the for kitchen design, and sonido, por favor. No lo oigo. No. Okay. Well, you saw the...
¿Así está bien?
Right, so this is a corpus we collected in a setting, the Wizard of Oz, in which there are 2 people simulating, one of them simulates to be this. We collected a huge amount of transactions and we analyzed them. And the purpose of this transaction was to offer a service. The machine offered a service essentially. And we wanted to understand the structure of the dialogues and also the structure of the tags. And it was a kind of important influence in the project. And one of the things we realized was that there is a structure in the conversation, a pattern in which the transaction had to go to a number of steps before it's completed. Even that's very simple. This transaction, we call it this well-behaved transaction, because as simple as you can get in this kind of dialogues. And we had the sentences, the utterances spoke by the system and the user in this size. And then we had the structure of the conversation. We had one plane we call obligations. Is the sort of information content and the commitments that people engage in a conversation. And the other side, we call it common ground, that is divided into 2 levels, agreement and understanding. That is this negotiation protocols that we are always carrying on in order to make sure that the people is understanding what we are saying, and we agree on the transactions, obligations, and we carry on with them, including the understanding level in which there are things like about the channel, like did you hear me, or can you say it again, things like that. This happen in all the dialogues. And at the end of the day, we have expressions, but these expressions really, the UCHAs express intentions, and there we have dialogue acts in that side, which are the intentions that are expressed and people during the dialogue. And they have this structure. We have this partition of the planes, and also we have, when a speech act is performed, we say that there is a charge on the conversation, and when this charge is attended by other speech act, then there's a credit, and then the conversation is balanced somehow, and we can go on. And the interesting thing is that the channel of the obligations is kind of independent of the channel of the common ground. So there are two levels that sort of go together, but nevertheless, both of these things had to sort of carry on well in order that the conversation goes successful. So we analyzed a huge amount of transactions and huge amounts of dialogues, and we proposed that the obligations and the common ground structures can be thought of as independent planes of expressions, and the dialogue acts can have a credit and charge import, and a successful transaction, in order that we succeed, must be complete and balanced in both of the channels. So it's kind of a principle, a guiding principle in design. And this was a very strong influence in our thinking about service robots. So because first of all, a service robot must provide a service. And then in order to do that, has to engage in communication. And there is the content, information content level, but also the other level is tremendously important in order to be successful. And there are many lessons with this project, but there are two that sort of were paramount in the emphasis. And one is that the main focus had to do with the interpretation of speech acts in order to understand, to engage in conversation. And the other is that the common ground structure is essential for reliable communication and interaction, and in particular, recovery protocols belong to the common ground. So a system, a robot interacting in the real world is going to fail all the time because noise, because misunderstandings and all that. But nevertheless, and it has to have recovery protocols, and they belong to this common ground structure and must be there in order to have successful communication. So, of course, this is very complicated. Speech acts can come in different modalities. Direct, for instance, when I say, please move the structure to the left, it's a command. I said it's an imperative, so I say it's a direct in speech act. But then maybe indirect, where I can say the same command with a question. I can say, could you please move the structure to the left? And if I say it in the right context, this question means do this. It's a command. But also it can be expressed with a declarative sentence. This structure is too much to the right. So it's an assertion, and nevertheless, it's a command, but requires interpretation, requires inference in order to be. And these things happen all the time in service dialogues, all the time. So the assumption that we can express a command in one particular form, direct, and expect that everything works well, if it's not like that for human conversation, how can it be like that for robot interaction, you see? So, and here the interesting thing is that inference is in service of communication, it's not in service of thought. I can communicate, and I need to interpret, and also I can think about the things I can do, but nevertheless, here the emphasis is in the communication part of it. Of course, interpreting speech acts is quite complex, and it's not just about the meaning of the words, not just about the syntax of the sentence, and not even about the semantics of the sentence. Consider this example, for instance. I like this example. You all know English. They say if the balloon popped, the sound wouldn't be able to carry since everything would be too far away from the correct floor. A closed window would also prevent the sound from carrying, since most buildings tend to be well insulated. Since the whole operation depends on a steady flow of electricity, a break in the middle of the wire would also cause problems. Of course, the fellow could shout, but the human voice is not loud enough to carry that far. An additional problem is that the string could break on the instrument. Then there could be no accompaniment to the message. It is clear that the best situation would involve less distance. Then there would be fewer potential problems with face-to-face contact. The less number of things could go wrong. Who understand this paragraph? I mean, you know English, you know the meaning of the words, you know the syntax, you can do inference, you can resolve pronouns, etc., and all that. So why, I mean, someone is not making sense of this, what is missing? So this kind of the top-down, this is the bottom-up information from the world into the systems, and nevertheless, something is missing. So it's not just about the explicit message. And of course, if I give you this picture, then the whole thing makes sense. Okay? Because you have a situation, you have a context against to interpret the whole thing. So then the point of this is that in order to interpret speech acts, the system must be in context. So, and the context must be represented, this knowledge somehow. That had to be operational in the interpretation act and had to be provided in order the system can make sense. And then we can say that the result of an interpretation is a representation. When you read the paragraph and you didn't understand it, you didn't build a representation in your mind. Or you didn't build a full, complete representation. So until the context is there, then you can build the representation and act at the intentional, at the communicational level. So the thing is that, but the interpretation is relative to the context, and we need to represent the context. So somehow the summary of all this is that, of course, the context is a big thing. The interpretation context is, I mean, there are many, many notions of context in computer science, and they're different, but one thing we can agree all is that this a lot of knowledge. So the question is, what knowledge? And, well, at least this. I mean, there is a set of agents in a situation. There's a special temporal situation, that is information, lexical information. There's discourse information, that's anaphoric, domain knowledge, the thing we are talking about. But essentially, the lesson that we had, or we believe we had from the DIME Corpus is that the dialogue and task structure must also be part of the context. So if we are doing interpretation engaged in this structure, then the interpretation problem is solved much more directly. So you saw the application, for instance, in the game. There are speech acts quite complex, partial, indirect, and nevertheless the system is able to carry on with the interpretation very easily by a very simple scheme. And the essential ingredient to do that, the way we could do that is because we have this representation of the dialogue and the task structure. But you could say at this point, well, but I mean, why do you need all this engagement and communication? I mean, if you are in a graphical interface, I can just point to the stoop and move it from one place to another, and that's it. Okay, so I don't need all that. But when you do that, I mean, the person who is solving the problem is thinking by himself. I mean, solves the problem in an internal way, fix all the parameters of interaction, and when that is done, then he can perform the action. But what we are saying, what we're seeing in these service dialogues is that the problem is not solved by this heavy thinking machine, but rather the problem is solved incrementally in the communication. And we have this dilemma. So on the one hand, in a strong AI sort of line, the heavy load for inference is in the thinking part. But we are thinking more in the HCI, then the load comes to the communication and to the inference part. What is the right balance to that? Okay, so and in this context, I mean, in order to build this robot, what we had to think or to do was to develop a simple model for representing the context, and it's what we did in this section with dialogue models and cognitive architecture. So I'm going to say a bit more or less the same from a different perspective. And to be in a context, I mean, for a robot, for a person, is to be situated. So we also talk about situated robots. So when a robot is interpreting, is in a situation. And what's in a situation? I mean, what is to be in a situation? Well, I think, I mean, that to be in a situation is an information state. So I have an information state, and I'm situated in relation to that information state. So, but the problem is, how much information do we need to put in a situation for a situated robot? Okay. So one possibility, in one extreme, I mean, we can say, well, we can represent situations and finite state machines. So a state is a situation is a state of a finite state machine. But the problem is that there is too little information there. I mean, a finite state machine is practically empty of content. The only content that we can think of a finite state machine is the arcs, the labels, and the next situation. But besides that, they don't have any information at all. They cannot even look back to the previous state to see where they came from. So it cannot be. I mean, so cannot be finite state machines. So we can go to the other extreme. And what's the situation? Well, we can say is the full knowledge of a person in a particular state. So I have the thinker. Okay. So, but think, I mean, for a second, if I were to need all my knowledge in order to act, I wouldn't act at all. It would be like playing chess or whatever. So it's too much information, and I need to react more rapidly. So a lot of information wouldn't be used, would be very hard to index, and all that. So it has to be less than that, much more less than that. Okay. So in order to build this framework, in order to do this dialogue interpretation, well, we say, well, a situation is going to be like that. This is what we sort of developed or thought as. A situation is a state within the task structure. So in terms of the speech acts task structure, a state in that. Where the agent has a set of expectations about intentional messages that other people can say, or there are expected events in the world that are meaningful in that particular task at that particular situation. So then the expectations and the intentional acts that we sort of model in the same way, even if they are natural events, is the information content of the situation. In addition, a situation might be structured, might contain a full task, so they had to be embedded. So they had to have a task structure. And for that, we can think of kind of recursive transition networks as the sort of formalism to model the thing. But in addition, the speech acts might be parametric. I mean, I might have a speech acts that are pretty concrete, but they might have parameters. So I can make a command, but the content might be a variable. So I need to have abstract speech acts. So then there's another requirement. So we have this framework that is like recursive transition networks, but we are a functional facility in order to define predicates, functional predicates, and full functions actually in order to be able to handle these situations. And also, a situation must have the dialogue history. Because we do need to resolve anaphors, we have to go back into what we said, and this, of course, is a very important part of the context in order to do interpretation. And also, memory, access, and reasoning must be available from the situation. So we needed a formalism that do this, but in a very, very simple way, because if it's complicated, well, we won't be able to do anything at all. So it's what we set up to do. And we have this formalism. It's what we call F, functional recursive transition networks. And this have this graph, but the only thing is that these S are situations in the sense I mentioned, with this information content, and the labels, the alphas, are speech acts at that level, maybe functional as well, and the betas are also speech acts, but that the ones the system produces, which are in general actions in general from the system. And also, they are functional in the sense that the speech act, the label, is not the only thing that determines the next state, but also there is a function in between that can be evaluated, that function H, in relation to history or other knowledge, and decide which is the next situation as well. So it's an additional degree of flexibility that is embedded in formalism. And a dialog mode looked like this, where it's empty means that you want to take that transition deterministically. G1 is a function that might be evaluated in relation to the context, to the history, and F and G2 and H are also functions, and more or less work like this. Suppose that in a particular situation, there is an offer that the system has to make between options A and B, and then the expectation is that this offer is accepted, and the interlocutor accepts A or B, and then when either of those options is accepted, then the system has to explain, for instance, what he offered to provide. Okay, and function H there decides, depending on the context, what happened before in the task, whether to go back to the same particular initial node in this case, or finish the task, because maybe I need to do more game into this offering protocol. So, and the history, and at the definition of the model, these are functions, but then when the concrete interpretations and actions have been performed, they are concrete. They are already in the history of the system, and there are concrete memories that can be made relevant during the task. So it goes like this. There is an offer, there is a stack when the history is provided, and the history has, the entry in the history is situation in the system where the expectation that was met, the action that was performed, and the situation that system went to. So this is in this little box, and then the protocol of the offer goes in this way. There is an accept, option A, explain, and then the stack contains the history of the concrete actions and expectations that had made until the protocol, the system decides to go to the final situation, and that is the dialogue structure involving all these speech acts that conform these abstract protocols of communication. But again, these speech acts are also not only about information content, but they are also about the agreement. And that is what sort of gives this more power to the network. So you may say, well, what happens if the robot is in a situation in which no expectation is met? Well, then is when the common ground is enforced. Then common grounds are recovery protocols, and common ground has recovery protocols that can be enforced in order that the system resolves why there is no expectation there, and then develop the protocol, set in context itself again, and continue with the interaction and with the embedded protocol. So also here it could be a situation for thinking. So if the expectation is met, and I have a protocol, and they have a task structure, then I have two things to do. One is to engage in communication and say, okay, I'm going to communicate, interact with the world until I solve the situation. But also, I can go inside and think, well, what happened? Why the expectation wasn't met? And then I can start a thinking protocol in order to solve the situation and get back into context by that way. Okay, so then the way the system works is that the dialog models is a data structure that is there, parametric, representing the context of the task, and there is an interpreter, which is pretty much written like a programming language interpreter, a Lisp interpreter, or basic interpreters. We say parameters, which the dialog models function as the programming environment. And the speech checks are what are continually evaluated, and the value is the action that the system goes in a very kind of strict canonical way. Now, of course, we have to embed these protocols in the robot. And for that, we introduced the notion of a cognitive architecture. And a cognitive architecture, more or less, there you can find several definitions, but one that I like is a modular system in which the main processing protocols are the same. It's an invariant. But the different modules and local processing protocols might be independent, and nevertheless, the whole system works all together. So it's what we did, and we proposed this cognitive architecture for our system, which has the dialogue models and the dialogue model interpreter as the center, which is the structure there that has access to semantic memory and the context, of course. And on this side, we have the input, that is the perception mechanisms, and the other side is the action mechanisms. Recognition is like speech recognition systems, some basic vision processing tools, etc. And the important thing is that the interpretation model has access to the bottom-up information, has access to the perceptual memory, which are the patterns that are stored there beforehand and available to the system in different modalities, but also the expectations are available to the system. So only the expectations that are current in the dialogue structure are relevant, and they select possible interpretations, and this constrains very, very strongly the way the information can be interpreted and makes, well, the flow of information quite straightforward. Then the dialogue model have action protocols, and depending on the particular interpretation act, these action protocols might be specified, defining concrete actions which are rendered by different modalities in the system. But in addition, I mean, so this flow of information, the main one, the communication cycle, involves representations because works with the product of interpretations. The interpreter produces interpretations. Speech acts are interpretations. Then the whole thing of dialogue models is that it deals with representations because are the product of interpretations. Okay, and that's a very important level of abstraction because speech acts are independent of modality. I can express intentions by speaking or by making gestures or many other forms, and that level of representation is independent of modality, and then I can abstract from different devices for input and also for the output. But of course, not all the information that had to be handled by a robot is representational. In fact, a lot of the things that the robot had to do had to be reactive, because in the world, I mean, there are many things that had to be reacted upon without interpreting the information. Interpreting is pretty costly. So there must be mechanisms in which a particular stimulus, there is a particular response. But the important thing is that when the information is reactive, it's not interpreted in relation to a context. It's context independent. So the dialogue models represent a context, and that allows interpretation. So that costs a lot. But a lot of mechanisms might be reactive. And we have this part, this module, that communicates the resolutions directly with rendering devices by these autonomous systems. They had maybe several autonomous systems in the robot. And there is a coordinator. And what the coordinator does is sometimes both behaviors might proceed in parallel. So the representational communication loop might go on, and at the same time, the system might be attending different reactive tasks, and this is permitted. But sometimes, the reactive model may need to take full control and might say to the dialogue model, stop, I have this urgent situation, we cannot communicate, I had to act, and then react, and then after that, when that's happened, then control is back. And also, there are situations in which the dialogue model might say, well, at this moment, I need to stay quiet. The autonomous system must be stopped. I'm going to do a little thinking. And then, when I'm done, then I can return back the control to that. So that's basically the coordinator does. Allows these three forms of behavior to coordinate the reactive information, reactive behavior, with the representational behavior. So this evolved in a concept of service robots like, look at this. This is the robot, this is space. And then the main thing in our robots is the communication loop involving interpretations. That is the guiding thing in the system. So the system is aiming to communicate all the time, okay? But of course, that is not enough. And then there is the reactive loop, which is embedded within the communication loop, okay? But independently. And also, of course, sometimes there is the need to think. I mean, sometimes. Sometimes we just talk without thinking. Because in that situation, I'm just reporting information that I already have read in my mind, in my memory, that I'm reporting. I'm not thinking. I'm thinking, but in a kind of minimal way, because I'm extracting information ready available. Okay, but I don't go into a kind of problem-solving, chess-playing situation, and I had to take lots of time before I can come back with an answer. Okay, and the important thing is that for service robots, and I don't know, in other possible situations, the intersection between the communication gap and the thinking is not that large. Okay. But it must be there. Sometimes the system needs to sort of, when we are thinking is communication is about getting in touch with the world, okay? But thinking has to do with knowledge, the knowledge that I have, and I have to see if the knowledge is consistent, what are the consequences of the knowledge, and all that. But it's not about communicating. It's a different function. And of course, they interact. So when I'm talking, I need to sort of review the knowledge a little bit, and then report the result of that. Although I said, I mean, there are situations in which I had to think hard, but then when I do that, I sit in my table and don't move and concentrate, and I hope no one comes into the room and hit me with a bat, because I wouldn't be attending to that, okay? So there are different functions. And so this is the conceptual model of our robot, basically. That is realized in the cognitive architecture that is centered in the dialogue models. And now, with this, we construct our latest robot, which is called Golem 2 Plus, or IIMAS, and which has a number of functionalities that essentially deal with the perception and action part of the system. For instance, I have the speech and language, for instance. Well, there's speech recognition system. It has live speech recognition, context-based language models. There are language models for each situation. Every time the system moves a situation, there's a set of language models that are relevant for that interpretation. Languages with, well, English, we do English for competitions. I'll say that in a little while. Spanish, because we have worked a lot in doing speech recognition for Spanish, we developed the corpus DIME CN, which is probably the largest corpus for acoustic information that is manually tagged in several levels for speech recognition and acoustic and phonetics, or computational phonetics of Spanish. And we use for speech recognition, for instance, for the one you saw, the first ones you saw are basically built with our acoustic models. And there is a coordination with audio localization. I'll say a little bit more about that. There are recovery and prompting strategies, and you use pocket sphinx and jack audio and directional microphone. So there is the syntax is simple, it's template-based generation. that is also encoded, is related in relation to the dialogue models. There are pull options for the same intention during recovery strategies. There is a coordination with the speech recognitions and use festival. And language interpretation, as I say, is context-based. We use shallow and deep parsing, word spotting, regular expression, propositional predicates, rule-based parsing with handcrafted grammars, frame-based grammars, and also statistical parsing in order to be able to have some predicates that have no full values in a particular time. So, but this kind of standard thing that we have implemented within the cognitive architecture. So, our current robot.
Please approach person, stay 3 seats away, and look at me.
Well, he's combined with the vision task.
Here you are. Please tell me your name. John. It is nice to meet you, John. Let me learn your face. Hello, person. Here you are. Please tell me your name.
Linda.
It is nice to meet you, Linda. Let me learn your face. I will wait the person who over here. You are John. Hello, John. What do you need? Hola. Did you say hola? Yes.
Okay. So the other functionalities are kind of similar. Let me show you, for instance, this one in open manipulation. Well, in open manipulation, for instance, we have at the moment 2 strategies. One with the commercial arm, we use inverse kinematics, and we do the standard strategy. This is placed in the robot, but also we are working in an in-house robot arm that is much more simple, and this is interesting because it has 2 strategies. One is global to direct the arm, but also has an arm that searches locally for the object it has to get. And its developing house is 10 times more cheaper than the ones that we had to buy. And it's a very interesting solution, very simple. It looks like this. So I like this very much because instead of solving, there is no inverse kinematics employed in this arm. It's just the vision recognition system build the 3D model, get the pose and position, and then the arm is able, can be placed at the level of the object, and then by the simple heuristic, using basic trigonometry, the local, the arm moves close to the point, but then the hand searches for the object, and there's a lot of room in order to allow there can be a large mistake, and nevertheless, it's pretty effective. So we are just developing that pretty recently, and we're pretty happy about it. Okay, so and another facility that we have developed is audio processing. I'll show a video. This is an important facility for robots. Is when there is a noise, we turn to it. It's a basic pattern of perceptual behavior. And this is pretty important in language because it's the basics in order to establish face-to-face communication. And when we establish face-to-face communication, we engage in conversation. Face-to-face communication is the basic metrics for language learning and use. And with that, it's also possible to interrupt. You know what happened here?
Follow me. Could you stay in front of me 6 feet away and make a gesture? I saw you. I will get closer to you.
tracking normally. Then
I don't see you. Please tell me where are you?
Golem, estoy acá. So this behavior is pretty important because it's engaged, but then this is recovery protocol that is working different modalities, and then it's very able, I mean, it's pretty practical in order to get engaged in conversation. That turns out a very important facility for the robot. Actually, we use our own audio localization system. With a array of 3 microphones in order to be able to detect the sounds of value that has been developed within the project as well. So I think I don't have time to show you a full task. I'm almost, but well, very quickly I'll start. For instance, this is a task that is called General Purpose Service Robot in the RoboCup competition. This is the basic scheme of the task in which the robot has to engage in conversation and do some commands that can be composed out of the basic actions without the system knowing in advance which are those. And
I am ready for getting instructions. Please open the door. Thanks for letting me in. Please give me the instructions.
Move to the sofa, introduce yourself, and leave the apartment.
Did you say move to the sofa, get the magic, and leave the apartment?
No.
Please give me the instructions.
Move to the sofa, introduce yourself, and leave the apartment.
Did you say move to the sofa, introduce yourself, and leave the apartment?
Yes.
My name is Golem. I am from National Autonomous University of Mexico. Nice to meet you.
For evaluation, I mean, we have an in-house evaluation methodology based in Paradise, which is standard methodology to evaluate natural language systems that maximize. We measure how whether the satisfaction of the user is maximized. There are quantitative evaluations about the success of the task, but also qualitative evaluation depending on the satisfaction of the user. And we have done this in the previous robot, but now we are going to have here in Mexico in next month the RoboCup competition. And 2 years ago, by October, more or less, that was confirmed, and we decided to make a robot for competition, before, taking the same basic methodology and system, but adding the proper navigation and vision and perceptual capabilities. And we built our first robot, for competitive robot, went to Istanbul last year in July. We did 15 plays. It was okay. We got lots of experience. And with that, we built a second version of the robot. And we went a month ago to Madura, to the Open German. We made third place. So we were pretty happy about it. And then also, we won the Mexican championship tournament. Of course, I mean, we are competing, testing our systems, our friends, so it was kind of a formal competition, but nevertheless, we were lucky enough. And now we are preparing all these facilities. We are going to present our new robot next month in the RoboCup competition, and we hope to do a good performance. And just well, this is the team. People, there are several academic technicians and students in the project with different specialties. But although mostly everyone has to work together, we have discussion tables pretty often pre-animated in order to make the coordination. It's a pretty nice team that we have from computer engineering, electronics, control. Even there is a project of image and design within the project. I didn't have time to talk about it in this session. And there is also the part of linguistics, in which we have students from the Faculty of Philosophy and Language that are engaged into that. And the whole environment is very, very transdisciplinary in terms of specialties and the way we work together. Yes, final reflection. I think the way we have approached this project is a good model for technological development in our environment here in Mexico, probably in other places in America Latina. We have the problem that we do research out of context. We are not really in touch. So people work by themselves, and then it's difficult to integrate different kind of pieces of technology. And the idea to have a product, a final product, and even with the final packaging involving disciplines, different disciplines, give the context for different disciplines, and then we can have our research questions motivated empirically by our own problems. Because another problem that we have is that we don't have the context, we sort of import the problems. We import the research questions quite often. And then that somehow is not pretty productive because we are sort of working in the second kind of stage and sort of subordinated to other lines, other researches, and it's kind of artificial in a sense, but it's sort of forced. So the idea that we sort of develop products in complete and fully achieved products, then, and the research questions are demotivated, but that, I think that's a very good thing for our environment. So this is the final reflection, and thank you very much. If you have any questions, I'll be happy to answer.
Just before question, let me give you just 3 announcements. First of all, today at 6 o'clock we are going to have a social event. So we are going to we are leaving from this location. So it's recommended that try to leave your computer or personal belongings in your room. So we are probably returning kind of late. And the second announcement for tomorrow, the people who are arranged to leave for tomorrow, just let us know what time are you leaving to the airport, so we are going to prepare for that. And the third announcement is that the session Growing Woman in Computing in Latin America has moved to the Chaca restaurant. So that's the announcement. So you have any questions for Professor Pineda? Any questions? You have any questions? Okay.
Profesor, bueno, felicitaciones. Anoche lo pasaron en un noticiero de TV Azteca y justamente era este mismo. Con el tema de tomar los objetos y mover los objetos, ¿cómo resuelven cómo piensan resolver el tema de la accuracy, de que sea muy fino, de que no vaya a estropear los objetos, de que pueda manipular objetos más finos? ¿Están trabajando en esa parte también que tiene ya ahora que ver con sensibilidad?
Bueno, o sea, no, I mean, the question is whether we are using some kind of touch sensitivity in the hand. And not yet, it's just infrared information that has 3 LEDs in the hand, and then it detects, it searches locally with this whether there's an object. So the important thing with this strategy, which is very, very simple, is that, well, first of all, we sort of put the arm at the level of the object, and then there is just this one-dimensional movement. And there is an objective which is provided by the vision system, whether the vision system, we are using the MOPET technology, which is pretty new, pretty advanced. It gives you a very robust three-dimensional view of the object and also the pose and the position. And then we just send to the center where it's supposed to be. But there might be a lot of mistakes. But the thing is that little hand works completely independently. And then when it sort of finds the object, grasp it and get it. And the work is done. I mean, they are involved. We have technicians, I mean, that, computer scientists, I mean, that sort of very pragmatically oriented, but in conjunction there is the people from industrial design doing the arm and the hand. And it's pretty exciting the way they look at these things. So when you put the product together, all considerations that had to do with the actual design of the hand and the arm in order to sort of be successful in the behavior. And also, of course, there is the control and electrical engineering that provide the movement. And the nice thing is that this is very easy. This project has been developed pretty quickly. It is possible because the whole infrastructure of the dialogue models and the cognitive architecture permits very easily to fit that into the actual behavior. So you see, it's more or less the kind of environment. But no, we haven't think of that yet, but it's possible. And but I think the most important thing is that yes, this is the detachment between the primary motor behavior from one hand, that is sort of the computer had to think about it, but the actual hand that is searching independently in a very, very detached way. This is pretty interesting, and it's very simple. Costs 10 times less than the arm that we have, that work with inverse kinematics, and it's much less precise, much more difficult to work with. And also, there's another thing, I mean, that we are here in Mexico, I mean, we don't develop really technology. I mean, we more or less buy technology. So and then we sort of incorporate that and disseminate it. It's good, I mean, it's important. But when these things of technology have a component here, the prices go down quite a lot. I mean, what it costs in dollars might be the price in pesos to that level. And so it's quite interesting to see this. I think the point is that we had to move into the situation of creating technology in a way that the things we do sort of form a part of the technological front. I mean, we want to be partners, active agents in the production of technology. We have to do these projects. And I think that's an important strategic objective for us to do.
Another question, a short question. Okay, yeah, Miguel.
That issue of putting technology on the production line. Do you have any strategy on how to build the bridge between academia and?
Well, it's cultural. Look, we have. Well, did you listen to the talk, the introduction talk by the subsecretary of?
Yeah.
Okay. So these are large figures, and of course, this question of the maquila. Okay, how much maquila, how much interaction there is. Okay, but the truth is that it's very difficult to find examples of high technology developed in Mexico, and there is a plan, there is talk, there is policies, but that way things don't really proceed much. I think it's more had to do with a cultural thing that people had to sort of. There must be cases, I mean, examples of success that people sort of know, well, this is possible to do these things. And then people start doing projects. I mean, because building the projects, I mean, designing things and building is the key to really do the development. So I think it's more a cultural thing than a political thing. I mean, the politics has been forever. Since I started my career 30 years ago, I started to attend seminars on that, and more or less the situation I saw at that time is not too much different from what it is now. I think what is important is that the mentality has to change, and the question is to build technology, to have projects that has as an end to build the final product. that has a high component of high technology. Because in the processes when you get the research questions, in the moment you have this, I need to build this high-tech device. Then you do the specifications, and then, of course, you're going to incorporate technology from everywhere, but eventually you are going to face problems that hasn't been faced before because it's your product, and that is the technological challenge. That is the question you had to answer, and then you had to do the technology. So it's the process I think technology is made. And of course, it's not a question of building technology as opposed to importing technologies. It's a concept of the last century. I think the question is to be an active agent in the international community, to be a partner in that. Because technology has products from everywhere. You have a cellular phone that's, I mean, how many patents has this one, and from how many countries in the world? A lot, okay? So you have your product, you have your idea, you have your design, and then you have to dress that up with technology the best you can get, and then that is the way to go in technology. So I think the strategy for Mexico should be that. I mean, to have these projects, find problems, solve them, and then be a partner with the international community, and why not with Microsoft? I mean, that's the thing. If Microsoft is a partner with Mexico, it's a win-win situation, because we are a larger product of technology, and Microsoft has a much more strong presence, and we both win. I mean, so we had to go onto that level.
Okay, thank you very much. And with this presentation, we finish this session. Thank you very much for attending the session.
Gracias. Thank you. Thank you.